Welcome to a short demonstration of the technical prototype that has been created on the project as planned at the BWI at the ETH Zurich. The idea of the project was to create something that can assist service managers in designing their service supply chain and making decisions regarding changes that should be made to improve their operations. In the next few minutes, I will explain you the main modules of the software and thereby show you how it works. So here on the left, we have the Project Explorer, which is mainly the location of all the files which are generated in the AsPlanned software, so all the simulation models. In this short preview, we will look at the Training 2 model. Down here, we have the Model Explorer. In the Model Explorer, you can see the start time of the simulation. You can select how many days you want to simulate, and you can review different parameters. For example, here we have a breakdown service, installation service, and maintenance service. Additionally, we can see the different technicians that work in our service supply chain. Here on the right, you have the service delivery process. So here we can use the EasyBPN standard to draw our service process. We can also input a lot of information which is relevant, or we have to input a lot of information which is relevant for our simulation model. Additionally to the structure of the process, we have data input, which you can open by clicking in the process modeler or clicking on this button. And here you can see that there's a lot of information required for the different entities of the model of our service supply chain. So here we have the assets, which are the machines located at the customer sites. The software allows to import from Excel, so you can export your data from an SAP system and then import it to the AsPlanned software via Excel. So here you can see we have the address of the asset, we have contract response time and a contract availability parameter which we can set, and a lot of more parameters. To show you what we can do with the software, I just delete here the GPS coordinates of one asset. And you can see I can use a function which automatically calculates the GPS coordinates, which are then used in the model for calculating, for example, the transfer time of a technician, or for deciding which technician needs to get this ticket or which technician is closest to a certain service ticket. Here we have the services, the different employees working in the service network, so field or service technicians and people working in the facility, so people working at the hotline dispatching and at the ticket closure. Then we can input also facilities, warehouses that provide spare parts. In this model, we do not model any spare parts. And we have all the information regarding the process elements. As I said before, the structure of the process is given in here in the drawing, but there is a lot of more information that is going into that. For example, we have a travel speed, which we have for the transfer. Here in the travel speed, you can see now another function. I open the function editor, and you can see here that I have selected a ticket parameter, which is MOT, mode of transportation. And so here I have two different speeds for a plane and for a car, which are used in the simulation. And they are used dynamically for the ticket, based on the mode of transportation of the ticket. So that could be a car if it's close and a plane if it's far away. Then we can also, which is very interesting, set the algorithms for dispatching and job planning. Dispatching refers here to the assignment of tickets to technicians in the field. Here we can select, for example, the distribution of maintenance installation tickets. So we have the parameters here as a shift type, so day shift, and then we have a contract parameter, which is the availability that a customer bought, so 24/7 in this case, which is called AV availability. And then the algorithm is that we look only at technicians who are in the same district as the asset, and then we select the least busy one. And if there's more than one, for example, two idle employees, we take the employee which is closest. So we optimize based on the actual distance. This was just to give you a short preview. There's a lot of more settings which you can configure to model your network. Then we also have a very nice editor, or not editor, more like a display of the information. So here you can see really all the assets that we have put in to the software worldwide. So you see here we have a big base in Europe, some in America, some in Asia, and we can zoom in even and click on each dot here, and then the information is displayed. So what kind of contract parameters, what installation date, in which city the asset is, or which postal code, the ID, and so on. And also the service technicians can be displayed. Now we will show you a short simulation run. So we will run the simulation for 200 days. What is now happening is service tickets are generated for all the assets, and then the process of service delivery is happening. So the service is arriving in the hotline, getting a priority, then dispatched to a service technician in the field. And these process steps here are then done in the field. So the technician has a certain number of tickets. In the job planning activity, he selects a new ticket, then he transfers to the customer, does an execution on the ticket, and if he doesn't have a ticket or if his shift is over, he transfers home. Otherwise, he takes a new job planning and the ticket goes directly to closure. So what you can see here is the process of the ticket itself. In each activity, the ticket needs to be operated by a certain person, which can be, in these cases, dedicated persons in the service center, or the service technician who does all the field activities. So the simulation has finished now for 200 days, and now the KPIs are calculated. The idea is that service managers can create different models and then copy these models easily and make variations, so they can improve them or change them by, for example, adapting the skill, hiring people, or transferring people to other locations, changing their dispatching logic, and so on. There are hundreds of possibilities what can be changed, and the idea is then to simulate these models and to look at them in the KPI. The KPI framework is a framework that lets you assess. Now I did two things at the same time. Okay, now it's loaded, which lets you access the performance of the simulation. So here you have the simulation run, and now I can click on all the entities in the model and look at some values. For example, I can look at my employees. Here we have a lot of statistics, for example, number of tickets per day, total time in the different activities on average, number of tickets, and so on, number idle or total time idle. Also, we have a visualization. So you can see here, this is the time the technicians have worked, and here are the activities. So you see they were traveling a lot because we have a global network and long distance. Additionally, you can display information about the tickets. So here we have the overall response times. You see for breakdown, which is a high priority service, we have a very fast response time of 11 hours worldwide. For maintenance, it's a bit bigger. And then you can go into more detail. For example, for the employees, you can only look at the service technicians. You can go even more detail and look only at the one employee. Open the one employee. See now, this is the activities that he was doing, and you can see for any date, you can see what he was doing. Now comes also a very nice feature, which is the geolocator. So you can see how a guy was traveling. And by seeing that, you can also click. You see this is now okay. Now that's appropriate. You can click here on each ticket and see, okay, this is destination number 33 and what kind of ticket he was doing there and what kind of service. So thereby you can verify your model and see what's actually changing in the process which is happening. There's a lot of more data here that you can display. For example, the activity data. You can see, for example, how many people were transferring at the same time and see some statistics about the activity transfer. So the average time spent on this activity was 4.7 hours with a deviation of 6.5 hours. We hope you enjoyed the presentation of our technical prototype. If you have any questions, feel free to contact us. Have a nice day.